Hey, Kat. Hey, Tyler. I was going to do Algebra 2 first, but since y'all are on here and there's no Algebra 2 people on here, I might do Algebra 1 first. Yeah, let me change papers. I'm going to do Algebra 1 first. Hey, Tyler, I'm doing well. How about you? All right. I'm going to wait just a minute more to see if anyone else wants to come on. And if y'all miss something from that I go over on the video, of course the video will be on the Facebook page for the group that you can go back and look at any time. Thank you, Tyler. Okay, so this is Algebra 1. I'm going to go ahead and get started, and if anyone joins late, they can go back and watch the video. The lesson that we did on Monday involved simplifying square roots. This is simplifying radical expressions with variables. So the difference in today's lesson and what we did Monday, this is what we did Monday right here. A problem like simplify the square root of 20. Today we're going to be adding variables under the square root symbol with our 20. So I'm just going to review this. This is what we did on Monday. And you should have an IXL lesson on that. If you haven't done that yet, this lesson might be a little difficult for you. Just make sure you go back and watch that first video on how to simplify these if you get confused. So first of all, the square root of 20. Remember, what you have to do is factor 20 into two numbers. One of them has to be a perfect square. And we went over what the perfect squares were. And a perfect square that will go into 20 is 4. So we factor the square root of 20 as the square root of 4 times 5. And then the perfect square, you take the square root of it and it comes on the outside of the radical. So that's going to come on the outside as 2 because the square root of 4 is 2. And then you're left with the square root of 5. So your answer is 2 on the square root of 5. Now that's a review of what we did Monday. Now we're going to add variables to the problem. Alright, so before we add variables to this kind of problem, let's go back and just review for a minute and recall what happens when you multiply variable expressions with exponents. When you multiply something like x to the third times x to the fourth, remember you add your exponents, 3 plus 4, and you get x to the 7th. So you're going to need to know that and remember that whenever we're doing these problems. So this says, so perfect squares with variables are different. The square root of x to the ninth is not x to the third, because x to the third times x to the third is not x to the ninth. It is x to the sixth, because you add your exponents. So whenever you're taking the square root of a variable with exponents, it doesn't work like it does when you take the square root of just a regular number. So here are some expressions with variables to show you what the perfect squares, how they work. These are all perfect squares. Perfect square variable expressions have to have exponents, or even exponents. So like the square root of x to the second is x to the first. The square root of x to the fourth is x to the second. Let me move that up so y'all can see it better. The square root of x to the sixth is x to the third. Now let me go back and explain, make sure you understand why. The square root of x to the second is x because x times x is x to the second. The square root of x to the fourth is x to the second because x to the second times x to the second is x to the fourth. The square root of x to the sixth is x to the third because x to the third times x to the third is x to the sixth. The square root of x to the eighth is equal to x to the fourth because x to the fourth times x to the fourth is x to the eighth. Do y'all get that? So you just half the exponents. The square root of x to the 10th is x to the 5th because x to the 5th times x to the 5th is x to the 10th. And then the square root of x to the 12th is x to the 6th because x to the 6th times x to the 6th is x to the 12th. So anytime you're taking the square root of an expression that has a variable raised to a power, you just half the exponents to get your answer. Let's see. So if I told you or asked you what is the square root of x to the 16th, you just half the 16 and it's going to be x to the 8th. Okay? So anytime you have an even exponent on your variable, that is a perfect square, and to get your answer, you just divide that by 2 or you half it and get something like this, x to the 8th. Now those are easy because you just half them, but you're not always going to have perfect squares with your exponents. Sometimes you're going to have odd exponents like this one, the square root of x to the 9th. And that's what today's lesson is all about, is how to simplify these kinds of problems that don't have even exponents. Everybody with me so far? Anybody need me to go back over something that I've done? Alright, so just to kind of review what I've gone over so far is we are finding the square root of expressions that have variables. And when you have variables, you have to look at the exponents. And exponents work differently than regular numbers do. And I just went over kind of why. It's because you add your exponents whenever you multiply. And remember, taking the square root of something is the exact opposite of squaring something or multiplying it by itself. So if you have an even exponent, to get the square root of it, you just half it, like I showed here on all these. Okay, but if you have an odd exponent, you can't just half it because it doesn't go evenly. If you divide 9 by 2, it doesn't go evenly. You're going to have a remainder. So we need to see how or what the process is to simplify problems like the square root of x to the 9th when the powers are odd. And that's what we're going to be doing in our next few examples. And I've got to get something to write on because it's bumpy. Alright, so back to x to the 9th. I'm going to kind of show you the process of what you have to do. And then I'll do all these examples. So just look up here at this one. If you have x to the 9th, what you want to do, it's kind of the same process that we did with the regular numbers. You want to factor it. You want to factor x to the 9th into 2 factors. And you want one of those factors to be a perfect square. And you want it to be the largest perfect square that is in x to the 9th. So all you have to do, if you look over here the way I factored it, you just have to take that 9 and subtract 1, and you'll get x to the 8th. That's the perfect square that's the largest factor that will go in x to the 9th. And so x to the 8th times x to the 1st is what we factor it into, because when you multiply those, that makes x to the 9th. So once you factored it, then you just take the square root of x to the 8th. And the square root of x to the 8th, I'm going to mark it out because it's going to come on the outside. Remember, you half your exponent, and that is x to the 4th. And then you have your square root of x. This one that I didn't mark out is still left under the radical. And that's your answer. So the square root of x to the 9th is equal to x to the 4th on the square root of x. So that's basically what we're going to be doing in these next examples. Of course, you know, it'll get just a little bit more complicated, like it always does. But I'm going to try to make it as easy as possible. Alright, on example 1, we're going to simplify each of these. So we have the square root of x to the 16th. And I'm going to pause right there in case anyone's going to copy these down. And I'll just give you a second to copy those down. I don't think I have anyone live here, but I'll just still pause in case anyone's watching the video later. I'll give you a little bit of time to copy those down. Of course, you can hit the pause button yourself. Alright, I'm going to zoom in just a little. So on this one, we have the square root of x to the 16th. Now, I went ahead and put an even exponent in there just to make sure you understood. When you take the square root of a variable expression that has an even exponent, it is a perfect square. So you just half the exponent, which is x to the 8th, and there's no factoring or anything to do because it was a perfect square. That's your answer. That's all you do. But then when you run into one like part B, that's the square root of x to the 7th, 7's an odd number, so we have to factor this one using a perfect square that goes into x to the 7th. So we'll start out by writing your square root symbol. Remember, you just subtract 1 from this exponent, which is x to the 6th, and then you have your times x to the 1st, because x to the 6th times x to the 1st makes x to the 7th. And then you take the square root of the perfect square, the one that has the even exponent. And when you take the square root of it, you half that exponent, which means divide it by 2. And when you do, you'll get x to the 3rd. And I marked it out because it comes on the outside. And then you have your square root of x left. Make sure you put the square root over the x. So your answer is x to the 3rd on the square root of x. That is your answer. Moving on to part C, you have the square root of a to the 15th. So again, 15 is an odd number. That means we have to factor this as a product of an a to an even exponent, which is going to be 14, a to the 14th, because you just subtract 1 from that. And then you're always going to have, I call it the leftover factor, because that's what it takes to make a to the 15th. A to the 14th times a to the 1st. Then you half the even exponent. I'm going to mark it out because that comes on the outside, and you get a to the 7th on the square root of a. So I hope you're noticing that on these that have the odd exponents, you're always going to have the square root of that variable to the first power left on every one of these. So let's go on to the next one, part D. Okay, square root of n to the 27th. 27 is odd, so we have to factor this. When you factor it, it's going to be n to the 26. Remember, you subtract 1 from that 27. And then you're just going to have times your leftover, your n. Because n to the 26 times n to the first is n to the 27th. And then you half the exponent. That comes on the outside as n to the 13th. And then you have your square root of n left. So your answer is n to the 13th power on the square root of n. Let me see if there's anybody with me, if anyone has any questions. Hey, Skylar. Thank you. You stay safe, too. Make sure y'all watch these videos, though, and try to do these lessons. You need brain power. This will give you brain power. Alright, let's go on to example 2 now. And I'll give you just a second if anyone is working with me to copy those down. Notice the difference in example 1 and example 2. Example 1 that we just went over only had the variable expressions, and now we're putting the coefficients in front of the variables. So now we got a combination of Monday's lesson and today's lesson. Alright, on part A, and if you didn't get to copy those down, then of course you can go back and look at the video and pause it when you want to and copy it. Make sure you understand what I'm doing. Alright, on part A, we have the square root of 18y to the 3rd power. So, obviously 18 is not a perfect square. Y to the 3rd is not a perfect square. So we're going to have to factor these so that we'll have some factors that are perfect squares that we can bring out of the square root. Because remember, the whole point is like shrinking what's under here, simplifying it, kind of like, not, you know, I kind of compare it sometimes to reducing fractions. You're just trying to shrink it, make it more simple. So any perfect squares that are in these expressions, we've got to bring on the outside. Okay, so for this first one, the square root of 18y to the 3rd. We're going to factor. Remember, when you're factoring 18, you've got to think of the largest perfect square that divides into 18. And on Monday's video, Monday's lesson, I gave you a list of perfect squares that you need to memorize. So it will help you with this. The largest perfect square that divides into 18 is 9. 9's a perfect square. So we're going to factor 18 as 9 times 2. Then moving over to the variable, we have to factor y to the 3rd. And you factor it into, I'll just put another times sign right there. You're going to factor it as y to the 2nd times y to make y to the 3rd. Then you go through and take the square root of the perfect squares. 9's a perfect square. Y to the 2nd's a perfect square. So those we have to bring out. We have to bring out their square roots on the outside. So you take the square root of 9, which is 3. So you write 3 down. You take the square root of y to the 2nd, which is just y because you half your exponent. And then you write your square root. And whatever's left inside that we didn't mark out goes on the inside to y. So your answer is the square root of I'm sorry, your answer is 3y on the square root of 2y. That is your answer. All right, moving on to part B. The square root of 50r to the 11th power. I'm going to start by factoring what's under the radical. Remember, when you factor it, you want to pull out the largest perfect squares that are in those, in that expression. So we're going to factor the square root of 50 as 25 times 2, because 25 is the largest perfect square that divides into 50. And then we're going to factor r to the 11th as r to the 10th times r to the 1st. Because remember, you want to subtract 1 from your 11 to make it an even exponent. Now you go through and look at your perfect squares and you mark them out and you take the square root of those. So I'm going to take the square root of 25, which is 5, and take the square root of r to the 10th, which is r to the 5th, because you half your exponent. And then you have your square root of what's left, which is 2 times r, or 2r. And that is your answer. I hope everybody's catching on. I don't think I have anyone watching live, so I'm going to just keep on going, and then y'all can look back at the video. Next, we have the square root of 125y to the 5th. So I'm going to factor this because that's not a perfect square. So when you factor, you want to think of the largest perfect square that will divide into 125, which is 25. 125 is the same thing as 25 times 5. And then for your y to the 5th power, you want to subtract 1, which makes it y to the 4th. And then you've got to have your leftover y to the 1st to make your y to the 5th. Okay, we have it factored. You want to look at your two perfect squares, 25 and y to the 4th. We're going to take the square root of those and bring them on the outside. The square root of 25 is 5. The square root of y to the 4th is y to the 2nd. And then we're left with what's on the inside. You have to put the square root back. 5y. So you have 5y to the 2nd on the square root of 5y. And then part D, the square root of 80x to the 4th power. Now, x to the 4th is an even exponent. That's a perfect square. So I'm not going to have to factor the x. I do have to factor the 80. When you factor 80, you want to think of the largest perfect square that will divide into 80, and it's 16. So you have 16 times 5 to make 80. And then just write your x to the 4th down, because it has an even exponent. You do not have to factor that. So you now look for your perfect squares, and those have to come out of the radical. So the square root of 16 and the square root of x to the 4th, we bring those out. The square root of 16 is 4. The square root of x to the 4th is x to the 2nd, because you half your exponent on the square root of 5 left, and that is your answer. 4x squared on the square root of 5. Let's see. We still have a couple more examples. So moving on to example 3. If you'll look, example 3 and example 4 are just a little different because we have we have numbers on the outside of the radical, but we did those in our video lesson on Monday also. So you should already know what to do with those. Alright, so you have 2 on the square root of 45w to the 10th power. 45 is not a perfect square, so we've got to factor that. W to the 10th is a perfect square, so we do not have to factor that. The 2 on the outside is going to stay with me until the end, so I'm going to just write 2 down again. I'm going to factor 45 under my radical. Remember, you want to use the largest perfect square that will divide into 45, which is 9. 45 is 9 times 5. And then your W to the 10th just stays W to the 10th because it's an even exponent. So now I still have this 2 on the outside that is there. I'm going to put a times sign behind it because we've got to multiply that 2 by what comes on the outside. So the square root of 9 is 3, so 3 comes on the outside. The square root of W to the 10th power, you half your exponent and get W to the 5th power. And then you have your 5 that's left under the radical. Now you multiply the 2 times the 3 on the outside and you get 6W to the 5th on the square root of 5. And that is your answer. We have one more to do that's like that. Actually, this one is a little bit easier, but sometimes students get confused with problems when they look a little different, even if they're easier. So if you'll see, this n on the inside doesn't have an exponent with it, and I just want to make sure you know what to do with this one. So we're going to start off the same way. This 3 just stays. And then I'm going to factor 50 because 50 is not a perfect square. So 50, you want to divide it by its largest perfect square, which is 25. 50 is the same thing as 25 times 2. And then this n has no exponent with it, so you just write it down as n. And then, just like always, you take the square root of any perfect square factors that are in here. And 25 is your perfect square. The square root of 25 comes on the outside as 5. You're left with the 2 and the n on the inside, so you just write it as 2n. And you still have to multiply the 3 that was already on the outside by this 5. So 3 times 5 is 15. That means your answer is 15 on the square root of 2n. And that's today's lesson. I hope it made sense to you. You really need to practice it because things will not stick with you if you don't practice them. Here is the assignment that goes along with this lesson. IXL, Algebra 1, EE2. On this one, you only have to get a SMART score of 72. Like always, if you want to get a SMART score of 100, it would be wonderful, and you'll get more bonus points. Because all of this, for right now, until we know what's going on with school, all of this is bonus points. It's also the lessons that we would be doing if we were at school. So try to go back over these examples, make sure you understand it, practice your IXL. Then if you have any questions, you can email me or just put comments on this and I'll try to go back and answer them. All right, I'll see you next time. Bye.